All right, here are solutions to quiz 4 from Math 112. We're going to use a calculator on this one, so I pulled one out just so you can see what I'm doing. So in this first one, we got the half-life of bryonium is 693 years, and what it says is if a fossil is 100 years old, what percentage of its bryonium should it have left? Which we'll need for this problem and the next one is this formula for exponential growth. And what it says is that the amount that you have at time t is equal to the amount that you start out with times e raised up to your continuous growth rate times the amount of time that we're talking about in question. So what we can do is we can take advantage of the fact that since we know its half-life is 693 years, that means, So what that tells you is that when t equals 693, if p0 was equal to maybe 1 for 100%, and p of t will be 0.5. So we can plug in here and say that 1/2 is equal to 1e. We don't know r, but we do know that t is equal to 693. So all we got to do is solve this thing. You don't even need the 1 there. I just put it to illustrate. Take the natural log of both sides, and you get that 693r is equal to the natural log of 0.5. So r, my continuous growth rate, is the natural log of 1/2 divided by 693, which we can figure out over here. We can figure out the natural log of 1/2. And then divide that by 693, and we figure out that our value of r is equal to approximately negative 0.001. In other words, negative 1/10 of 1%. And we're not done because the question asked what percentage should be left after 100 years. So we haven't answered the question, but we have figured out the growth rate, which will be the key factor. So now that we know the growth rate, we know that the amount left at any time is whatever you start out with times e raised up to, instead of rt, raised up to the negative 0.001 t. So what we want to figure out is if t equals 100, what should p of t be? Well, we can solve that. P of t is equal to p0 is 1, e to the negative 0.001 times t, which is 100. So 0.001 times 100 is, maybe I should write more, talk less. This is just e to the negative 0.1. Okay, so all we gotta do is figure out what is e to the negative 0.1 power. You get this little e to the x button down here. So if you hit second natural log, you get e raised up to the, and then we want negative 0.1. And what you get is that this is equal to 0.9048. I don't know, 905 maybe, good enough. Say approximately 0.905 or 90.5%, 90.5%. So that's how much should be left after 100 years, which makes sense if it takes 693 years to cut in half. After only 100 years, yeah, 90% left. Sure, that seems reasonable. And this next one says, how long would it take, so now we're going to solve for t, for a fossil to decay to the point where it only has 15% of this stuff left. In other words, if it starts out with 1, it's left with 15% with a growth rate of negative 0.00, two zeros and a 1. How many years? T. It's saying solve this thing right here for t. It's not too bad. Just take the natural log of both sides. We get natural log of 0.15 is equal to negative 0.001 t. So t is equal to the natural log of 0.15 divided by negative 0.001, which we could figure out. Got a natural log button here. Natural log of 0.15. Then we want to divide that by negative of 0.001. And what we get is this number. T is approximately, what, 1,897 years? So how long would it take for a fossil to decay to the point that it only has 15% of it left? Approximately 1,897 years. I don't really care if you write the unit, but if you do, good work. Okay, determine the following without a calculator. Without a calculator? All right. See you later, buddy. Make sure to rationalize the denominator where applicable. All right, so first it asks me what is sine of pi over 6. I don't know, a few different ways to figure this out. If you have your unit circle memorized, maybe I can just kind of draw the first quadrant of my unit circle here. I get that there's 3 important points here. Well, I guess there's really 5. Got this one here and this one here. This guy's 1, 0, this one's 0, 1. That's not that important. The sine is the y value. And then what happens with the y value is that it goes 1/2. So I should write it over here. Root 2 over 2. And root 3 over 2. Whereas the x value kind of does that same thing but backwards. So it's root 3 over 2, root 2 over 2, and 1/2. We kind of have part of our unit circle here. Really the only one we care about is this bottom guy. This is pi over 6. These other two are just here kind of as reference, I guess. So since the sine is the y value, I get the sine of pi over 6 is just 1/2. And cosine of pi over 6 is just root 3 over 2. So those, I guess they're just more memorization at this point. But then tangent, maybe you remember that tangent is sine over cosine. So it's sine of pi over 6 over cosine of pi over 6. I already figured out that sine of pi over 6 was 1/2. Cosine of pi over 6 was root 3 over 2. So dividing fractions is like multiplying fractions, except you multiply by the reciprocal. So instead of root 3 over 2, I get 2 over root 3. Those 2's cancel, and I get 1 over root 3, which is not quite done, because I have to multiply by root 3 over root 3 to rationalize the denominator. And so what I get is that tangent of pi over 6 is the square root of 3 divided by 3. Okay. Cosecant. Cosecant of pi over 6 is 1 divided by sine of pi over 6. Sine of pi over 6 I know is 1/2. So it's just what is 1 over 1/2. I mean, you might be able to just figure that out, but here's one way to write it up. Fraction divided by a fraction. It's like multiplying fractions, except you multiply by the reciprocal of the denominator, you get 2. Similarly, secant is 1 over cosine of pi over 6, which is 1 divided by root 3 over 2, which I guess is 1 over 1 divided by root 3 over 2, which is 1 over 1 times 2 over root 3, which is 2 over root 3, but if you rationalize the denominator, it's 2 root 3 divided by 3. I don't know why some of these get a box and some don't. Guess I should add a few there. And then finally, cotangent of pi over 6. You can either say cotangent is cosine over sine. So this is, I guess, cotangent equals cosine over sine, or 1 over tangent. You can use whichever identity here you want. I think 1 over tangent is probably a little bit easier. So I'll say this is 1 divided by the tangent, that's an equal sign, not a minus, of pi over 6. And I already figured out that the tangent of pi over 6 was root 3 over 3. So what I get is this is 1 over 1 divided by root 3 over 3, which is 3 divided by root 3, which if you rationalize the denominator is 3 root 3 over 3, which simplifies to just root 3. So what I have are my 6 trig functions evaluated at pi over 6. And I suppose that is the end of the quiz.